Okay, so I'm going to look at 12.6 tonight. So Hart Manufacturing makes 3 products. Each product requires manufacturing operations in 3 departments, A, B, and C. The labor hours required by departments are as follows. So we have departments A, B, C. We have product 1, product 2, product 3, and that's the labor hours requirements. So during the next production period, the labor hours available are 450 in department A, 350 in B, and 50 in C. The profit contributions per unit are 25 for 1, 28 for 2, and $30 for product 3. So then we're supposed to A, formulate a linear programming model for maximizing total profit contribution. B, solve the linear program formulated in A. How much of each product should be produced and what is the projected total profit contribution? And then C, after evaluating the solution obtained in part B, one of the production supervisors noted the production setup cost had not been taken into account. She noted that setup costs are 400 for product 1, 550 for product 2, and 600 for product 3. If the solution developed in part B is to be used, what is the total profit contribution after taking into account the setup cost? Then D, management realized that the optimal product mix taking setup cost into account might be different from one recommended in part B. Formulate a mixed integer linear program that takes setup cost provided in part C into account. Management also stated that we should not consider making more than 175 units of 1, 150 units of 2, and 140 units of product 3. Then we're supposed to solve the mixed integer linear program formulated in part D, and how much of each product should be produced, and what is the projected total profit contribution. Compare this profit contribution to that obtained in part C. So hopefully I can remember to do all this. So for the first one, let's let P1, P2, P3 be the units of product 1, 2, and 3 produced. And then our max is what we want to maximize is the total profit contribution. And so we know that $25 is the profit for unit 1 or product 1, and 28 for product 2, and 30 for product 3. So we want to maximize those 3 added together. And what we have to do is such that, well, we have to take the labor hours, 1.5 times P1 plus 3 times P2 plus 2 times P3. That has to be less than 450 for department A. And then for department B, then we just use the criteria here and the 350. And product department C, we use these coefficients times P1, P2, P3, and then that has to be less than the 50, less than or equal to. And we just know the only thing we really can tell is P1 times P2 times, or P1 and P2 and P3 are greater than or equal to 0. Sorry about the voice and how I'm messing up. I'm sort of sick, but all right. So this is what we need to do. We need to set up a model. And so we have our parameters. And this is basically the same thing as we have here, except we've added the hours available. Okay. And that's just so we have those available in our calculation. And what we want to do is we need the profit contribution. Well, that was the 25 for P1, 28 for P2, and 30 for P3. That's what we're going to maximize. Then for our model, well, we need to find out the amount to produce for P1, P2, P3. What is our profit? Well, that's the sum product. We're going to take the sum product of the B12 to D12, which is right here, taking that and that times B17 to D17, whatever number that's in here. Okay, so it's going to come up with that number, and we're going to use our solver to figure out the numbers here, and then this is just going to come out to find the profit. Then our hours used, that's pretty easy. It's just, again, it's going to be that B7, D7, this row, times the amount produced here. So we're just going to take it times those. And we're going to do that for department A, B, and C. And that's going to be, the only difference is the different values. We're going to use the B row, the C row for the bottom 2. Okay. All right. So now, since I can never remember how to do this, I just went ahead and copied this. I did it once to make sure everything worked. And then I copied it in here. And so now I just have to type it all in here. All right. So B19 is going to be our objective. That's what we want to do. We want to have our profit to be maximized. And so that's the maximum. And what are we going to change? Well, we're going to change this. That's what it's going to be changing. And it didn't change what I wanted it to do. It wants to change that one. And what are their constraints? Well, our constraints are basically the Let me scroll down here if it'll let me, and it won't. Okay, so let's add. That'll be easier. So our constraints are the B22 to the B24, and that has to be less than or equal to the hours available. So these hours used has to be less than or equal to the hours available. And so the way we do that, we could just kind of highlight that, and then we want less than or equal to, and it has to be less than or equal to that. And we can either add it or we can just say okay, because that's all we're going to do. Oh, I didn't do it again. Okay, so with that and that time it worked. All right, and we went the simplex LP, and so I think that's all we need to do. So we solve. It says it found it, so we're going to keep that solution, and so that's what we're going to get. Okay. I don't know. Let's see. So once it gets it solved, then it gives us this. Okay. And so now we know the hours used is actually going to be the hours that are available, and that's going to be the amount to produce for each one of those. And our profit is 5,540. Now remember, it said part C, after evaluating the solution obtained in part B, which was at 5540, we forgot to take into account the setup costs. So they said it's going to be 400 for product one, 550 for two, and 600 for three. And so what I did then was, okay, well, if we go in here and do all that, 400 plus 550 plus 600 is 1550. And so we're going to take that 5540 minus that 1550. And so our new profit will be 3990, taking into consideration everything we needed to do. All right, so now for D, I think I might have copied this over here, yes. Now what we need to do is management realized that the optimal product mix, taking setup cost into account, might be different from the one recommended in part B. So now we need to formulate a mixed integer linear program that takes setup costs provided in part C into account. And management also states we need to have more considerations, not making more than 175 units of one, 150 of two, or 140 of three. So what we're going to have is the variable yi is what I'm putting in here, and it's just going to, just because we have p, so I just use y's. That's going to be equal to 1 if we actually produce the product 1 or I, or whatever value it is. Otherwise, it's going to be 0. And so that's what the y's are, 0 or 1, depending on if we produce it or not. And we know that P1 has to be less than 175, P2 has to be less than 150, and P3 has to be less than or equal to 140. And so then we just multiply it by that. And then to make these equations kind of more along the lines of what we've been seeing with just numbers here on the right, we're just going to take everything to the left. And so it's all less than or equal to 0 over here. And then we can go ahead and make a new linear programming model. And so our new one is same here, but now we're going to subtract off those costs. Okay, so remember we had the cost of setup for 400, 550, 600. And so if we produce product 1, that's going to be y1, so that'll be a 1. If we don't produce it, that'll be a 0, and so 0 times 400 is 0, so it won't matter. Same thing here. If we produce product 2, we'll put a 1 here, so then we'll subtract off 550 for the setup cost. Otherwise, it'll be a 0 and be no deduction, and same thing here. Now, excuse me. These pretty much are the same as what we had over here, so not much difference there. Okay, the new difference is we're adding these. So P1, remember we're taking everything to here, so it's going to be minus 175 y1 is less than or equal to 0. Then P2 is minus 150 y2 less than or equal to 0. And P3 minus the 140 y3 less than or equal to 0. And our p's again are all greater than or equal to 0. And the y1, 2, and 3 are either 0 or 1. Okay, so now we've done that. And now what we need to do is solve the mixed integer linear program formulated here. So again, to make things easier, instead of having to type it all out, I've kind of typed it all here, and then I've copied what I want to type into the solver so I don't forget. So here we have the parameters, and again, everything here is we've seen before. We've seen this here, that's a profit contribution. Now the max production, that's the new thing. We set those limits over here. We said that they can't be more than 175, 150, and 40. And then our setup costs, we added those in, and that was really kind of from part B or C here when we said, oh, well, we really forgot to put the setup cost in, and so that's where that's from. Now we're going to change, or we're going to be searching for the amount to produce of product 1, 2, and 3, and then this. So what we need to do then is find our profit. Well, our profit basically is going to be the B12 to D12. So that's going to be from here to here, the profit, just that times that times that times that. And then if we're going to produce it, then it's going to be times how much we're going to produce it by. So if we produce it, we're going to take, amount to produce times the profit, amount to produce times the profit. And then we're going to subtract off the setup cost. So the 400 times if we're going to produce it or not. So that's going to be a 1 or a 0. These are all going to be zeros or ones. Produce, yes or no. 0, 1. All right. And so if we produce it, then it's going to be times 1. So 1 times 400, that'll be 400. So we'll subtract that off, and then subtract off the 550 times this if it's that case. Same here. And so that will be a more complicated sum product of two things, but the difference of them. Hours used, it's going to be basically the same thing. It's going to be this item here times the amount to produce. So it's 1.5 per unit, and if we produce or not the B19, say 5 units or 10 units and 7 units, then we take that times the appropriate values up here. Same thing here, except now we're doing the department B, and then here we're just doing department C. Okay. And then capacity, this is just going to be if we were going to produce it or not. So if yes, it's that times the max amount. Okay. And here, this is going to be if we produce it or not here times the max amount. And here it's going to be that times that if we produce it or not. Okay. So that should give us everything we need there. And so let's go to solver. And so let's go ahead and make sure we get everything here. So we want B21, that's a profit again. And we want the maximizing it. And we're going to go from B19 to D19 and also that. Okay. And then we have a couple constraints, 3 to be exact. So these are going to be binary. And so that's going to be equal. And just binary. So add that. Okay. Oh yeah, I have to type it there. And then we do the next one. So that's going to be this, the amount to produce has to be less than or equal to, and it's going to be less than or equal to these values, our capacity. And I forgot to change that, didn't I? All right, so that is going to be less than or equal to that. Okay, so make sure I have everything right. That looks good. And then our last one is these values, hours used, have to be less than or equal to the total hours possible, which are these. Okay, and that should be all of our constraints. Let's make sure they look like what we want them to be. B21, B19, D19, and B18, D18. Those have to be binary. And that's going to be less than or equal to that. Okay. And so the only thing we have to do is put it back to simplex and say solve. Okay. And it gives us a value. Now that gives us our values here. Okay. So it looks like we're not going to produce any product 3, only product 1 and 2. And so our capacity is going to be maxed out for those two. Going to be 0 here. Our departments, they're going to use all the hours, and we're going to have 43.50 for our total profit. Now, I forgot to write the rest of this one. Now, how much of each product should be produced? What is the total profit contribution? Now, compare this profit contribution to that obtained in Part C. Well, Part C, if we compare it to this one, it's one thing. If we compare it to this one, it's a different one. So if it's this one, which is where we take into consideration the setup costs, which would be more accurate in this case, would be $39.90 versus the 4350. So here we make more profit. So this is definitely the way to go to tie it all into this more complicated system than the simple one here where we just say, okay, well, we just subtract off the setup costs for all of them, and then that's the value, because we're not actually going to produce them all in this scenario. We're not doing product 3, we're just doing product 1 and product 2. All right, so hopefully that will help you at least with 12.6, and then any others that are kind of tied into with that one.